once again, it's Mark's story in Bellevue College. This is our fourth video in the Symbolic Logic series. We've taken a look at how to develop and set up truth tables. We've taken a look at what to do with truth tables if you're dealing with a single statement. Today, we'll take a look at pairs of statements. Woohoo! I've got a table set up here. We've got a pair of statements, and what you want to do is have a complete one truth table underneath both of them. Don't do separate truth tables. It'll mess you up, trust me. Now that I've gotten students doing one truth table, most of them do fine on the test problems with this. So do one truth table. Again, count the number of different letters. In this case, we have P's and N's, 2 different letters. So we've memorized that'll be a 4-line truth table. So we've got it set up with 4 lines. We took our 4, cut it in half, 2 trues, 2 falses under the first letter. Then take the 2, cut it in half and get 1. 1 true, 1 false, 1 true, 1 false. And the truth table set up. First thing we want to do to get these blanks filled in is be consistent. If the P's are supposed to be true, true, false, false, let's make all the P's true, true, false, false. And I'm going to write that down. Okay, so we made all the P's true, true, false, false, just being consistent. We'll do the same thing with the N's. If the N's are true, false, let's make all the N's true, false, true, false. I'll do that. Okay. Now we can start filling in other kinds of blanks. Again, after you get the letters done, you might want to look at tildes that are touching letters. They're right next to letters, like this tilde right here. All it's going to do is negate this N column. If N is true, false, the tilde column will just be the opposite. False, true, false, true. I'll write that down. Okay. And we'll do the same thing with that tilde. If the P column is true, true, false, false, the tilde just negates it. We'll make it false, false, true, true. Okay. And we got all the tildes done. Really, all we have is the main operator of this left statement and the main operator of the right statement. I'll go ahead and star the main operator columns because those are going to be the important columns that'll tell us some things. We've got a horseshoe over here. So the only way a horseshoe will come out false is if you have the tough situation. Say right here. TF. All these others will be true. And we'll do the same thing with this horseshoe. The antecedent is the tilde, because the tilde is the main operator of tilde N. I'm also going to look at that tilde, because it's the main operator of tilde P. And again, I'm looking for the tough situation. I see one right there in row 2. TF, that one will be false. It's the only way to make a horseshoe false. All these others are not tough. That is, we don't have a true antecedent false consequence, so they'll be true. Now we've got a complete truth table. Now, what we need to do is a couple things here. Now that we've got the truth table all set up, what we do is we read it, and we're really only looking at the main operator columns. If the main operator columns agree on every single row, that means they're the same. They're saying the same thing. They are logically equivalent. If they disagree on every single row, they're fighting each other constantly, we're going to say they're contradicting each other. They're contradictory. So these are going to be logically equivalent, contradictory. Or neither. Neither is not a special word. It just means they're neither logically equivalent nor contradictory. Let's see how it works here. In row 1, they're both true. They agree. In row 2, they agree. They're both false. In row 3, they agree. They're both true. In row 4, they agree. They're both true. So they agree on every single row. That is, this column matches up perfectly with that column. That tells me these two statements are logically equivalent. If they've been opposite every time, true, false, false, true, then they'd be contradictory. If they agree on at least one row and disagree on at least one row, then they'll be neither. They're just two statements that are just hanging out there doing absolutely nothing, probably. That's one thing we can do with this table. Without doing any more work whatsoever, we can also determine if the statements are consistent or inconsistent. And what you want to look for here is, again, that main operator column, and you look for a row where they're both true. If they're both true, that means it's possible for them both to be true. If it's impossible for them both to be true, if they're inconsistent, then there will be no way they can both be true. There will be no row where both sides are true. One side will be false, the other side will be false, or maybe both sides are false. Imagine I'm a police officer. I catch 2 guys. I think they are the 2 people who robbed a liquor store last night. I take one guy, put him in one room, put another guy in the other room, and I ask him questions. I say, where were you last night? To the first guy. If he says, I was at the Mariners baseball game with my buddy, fine. I go to the next room. Where were you last night? And if he says, I was eating pizza with my buddy. Well, it's possible they could be at the Mariner game eating pizza. So it's possible both those stories are true. They're consistent. I'm not so sure if I've got the right people. If, however, I talked to one guy, and he said, I was at my mom's house with my buddy eating pizza. And the other guy says, I was at the Mariners game with my buddy eating, all night long. Well, they can't both be true, unless this guy's mom lives in the Mariners stadium, which isn't likely. These statements would be inconsistent. They can't possibly both be true. And that's what we're looking for here. If it's possible that they're both true, and this first row shows it, that means they're consistent. So we can do two things once the table's completed. We can determine if the statements are equivalent, contradictory, or neither. And we can determine if the statements are consistent or inconsistent. That you can study on your own, but you've now seen how to set up a table. The biggest thing is do one table for both statements. Set it up on the first and second letters, and then just fill the blanks in consistently. That should do the job for you.